Hello everyone, welcome to my channel. In today's video, we will discuss two questions of mathematical physics that were came in CSIR-NET July 2025 exam. So let us start. This is the first question. So here it is given that the solution of the differential equation dy by dx is equal to minus x divided by y plus 1 are a family of, and we have these options. So basically we are given this differential equation, and we have to solve and choose which option is correct. Like we have to choose whether this differential equation represents ellipses with different eccentricities, or circles with different centers, or circles with different radii, or ellipses with different foci. Okay, so now let us solve this differential equation to get our correct option. So this is a simple differential equation which can be solved by using separation of variable method. So by using separation of variable, we separated the y terms into one side, and here is the x terms into the other side, and then we integrated both sides and just simply solved further by doing simplifications, and c is the integration constant, and we finally reached here in this equation. So at this point we can write this equation by in this form. By simply adjusting, we can write it in this form, because this is a standard form of a equation of a circle. So we just have write this x square as x minus 0 whole square plus y plus 1 whole square. Then we replace this 2c plus 1 with r square. Now this equation, the above equation, is the equation of circle. The center is at 0 and minus 1, as you can see. Center is 0 and minus 1, and r is the radius of the circle. This r is the radius of the circle, and we have r is equal to 2c plus 1, root r is equal to root 2c plus 1. Okay, now since this integration constant c can have different values, so and r depends on it, so r also can have different values. So this gives us a family of circles with different radii, because due to different c values we will get different values of r, and hence we will get different circles of we will get a family of circles with center at 0 and minus 1, but with different radii with changing the value of c, or we can say changing the value of r. Okay, so here the option 3 is the correct answer, circles with different radii. So this differential equation represents a family of circles with different radii. Okay, I hope this question is clear to all of you. So option 3 is correct. So let's go to the next question. This is the next question, question number 2. So we are given here a complex function, that is fz is equal to exponential z minus 1 plus 1 by z minus 1. So we have to tell whether z minus 1 is a pole of order 1, or z minus 1 is an essential singularity, or z equal to 1 is a pole of order 2, or whether it is a removable singularity. Okay, so to check this, let us solve this further. So in the solution, let us first put this z minus 1 is equal to t for simplification. So for simplicity we have taken z minus 1 is equal to t. So now this function becomes ft is equal to exponential t plus 1 by t, as we put z minus 1 is equal to t. Okay, so now this let us we expand this exponential function about t equal to 0. Okay, so to find the singularity, type of singularity, we need to expand this. So simply if we expand the function in general e to the power x, if we expand it about x equal to 0, we generally get this series. Okay, 1 plus x square by 2 factorial plus x cube by 3 factorial, and so on. So similarly, if we expand this function, this exponential function, we will get the same series Here the x is replaced by t plus 1 by t. Okay, you can observe this is the same series as this one, just in place of x we have t plus 1 by t. Okay, so in the next step I have written this term as it is. Then this term, if we open the square, we will get t square plus 1 by t square plus 2. Then but to find the singularity, the t terms in the numerator are not important, so I just have written the 1 by t square term, and then from here if we open this cube, then we will get a 1 by t cube term. So again I have written that here, leaving everything else. So I have written this as 1 plus t plus 1 by t plus 1 by 2 factorial t square plus 1 by 3 factorial t cube, and so on. So now since we have taken z minus 1 is equal to t, so we can simply replace t by z minus 1. Okay, so now we can see that there are infinite number of z minus 1 terms present in the denominator. Like here this is z minus 1, here it is z minus 1 whole square, here it is z minus 1 whole cube, then it will be z minus 1 power 4, then it will just continue till infinity. So since this z minus 1 term is present in the denominator infinite times, so this means z minus 1 is an essential singularity, because when a term is present, when a term is present like z or z minus 1 infinite times in the denominator, so we call that the corresponding singularity is an essential singularity. Okay, so here z minus 1 is an essential singularity which is given in option 2. Okay, so option 2 is the correct answer here. So I hope this question also clear to everyone. If there is any doubt, you can obviously ask in the comment section. I will happy to answer you all. So that is all for today's video. Thank you so much for watching. Let's meet in another video. So till then, thank you so much. Bye bye.